Assalamualaikum warahmatullahi wabarakatuh. My name is Zahir Ismail. I am from EC1104E and my student number is 2020476128. In this video, I am assigned from my lecturer Sir Mustaqim to conduct an experiment for my mini project. The experiment that I will show you in this video is, the first one is the moisture content, the second one is particle density, the third one is particle size distribution, the fourth one is field density by using sand replacement method, and lastly, to find the probability by using falling head method. Let's proceed to the video. The objective of this assignment is to expose students with the laboratory work in soil engineering and improve students' ability to discover and innovatively conduct certain soil engineering tests within the vicinity of their area. There are 5 main objectives of this mini project, which are for moisture content, particle density test, particle size distribution, field density and permeability of soils. For moisture content, the objective is to determine the water content within soils. Next, for particle density test, the objective is to determine the specific gravity of soil using density model. Then, particle size distribution objective is to determine the percentage of different grain size contained within a soil. The mechanical or sieve analysis is performed to determine the distribution of the coarser, larger size particle. Moreover, field density by using sand replacement method is to determine the density ρD of in situ soils. Lastly, falling head test is to determine the coefficient of permeability of fine grained soils. Then, for the background study for this mini project is to determine the characteristic and properties of soils at my area, which is, in this case, undisturbed soils in UiTM Jengke. An undisturbed soil sample is one in which the soil's structural integrity is preserved and its recovery rate is high. Based on the research I make, the soil I use is an undisturbed soil sample. The apparatus that is used in this experiment is soil samples, dish and weighing scale. First, we weight the dish, and then we weight the dish with soil sample. After that, we put the dish with soil sample into the oven and leave it for 24 hours. Then we weight the dried soil sample with the dish. This is repeated for the other two dishes to get the average values for the moisture content. This is the data that I got from the moisture content. Moisture content experiment using oven dry method, several data were taken. The mass of pore water for the soils are 11.8 gram, 11.88 gram and 11.89 gram. Next, the mass of pore water taken were 5.01 gram, 4.84 gram and 4.83 gram. Lastly, for the moisture content, 42.46%, 41.24% and 41.46% for each soil samples. The average water content calculated was 41.72%, and by determining the moisture content of the soils, it helps engineers to choose soils that can be used in construction activity. As a conclusion, the objective of this experiment was successfully achieved, which is to determine the moisture content of the soils. The apparatus that is used in the experiment is density bottle with stopper having capillary hole at its center, wash bottle with DAD distilled water, vacuum sets, and weighing scale. First, we weight the density bottle with the stopper. Then we weight the soil samples with the density bottle and the stopper. Then we weight the soil sample with fully water in the density bottle with the stopper. We fill the density density bottle fully with distilled water and put the stopper on. Make sure there is no air trap in the bottle. Then we wet the density bottle with the stopper that is filled fully with distilled water. This step is repeated for the other two density bottles to get the average result. This is the data for the particle density test. Particle density experiment, the test was done 3 times to get the average specific gravity, and the specific gravity for this experiment is 2.53, 2.47 and 2.29. Conclusion: the objective for this experiment was successfully achieved, which are to determine the particle density and specific gravity of soils using density bottle and the moisture content of the soil sample. There might be systematic and random error during the conducting this experiment that affect the data taken. There is error during weighing the soil sample on the weighing scale, where the scale does not show consistent weight for the soils. Lastly, to get a better result, at the end of the experiment, several tests must be done and the values can be averaged. The test that is used in this experiment is weighing scale, set of sieves, cleaning brush, mechanical sieve shaker, lead and receiver. For the first stage, we weight the set of sieves one by one. Then we pour the soil samples onto the set of sieve and put the lid on. Then we attach the set of sieve onto the mechanical sieve shaker. Wait for 15 minutes and remove the set of sieve. After that, we weight the set of sieve again. For the second stage, we just use half of the soil samples. Weight the half of the soil sample. Repeat the same step for the second stage. This is the result for particle size distribution, and the graph was plotted. Particle size analysis is widely used for classification of soils. Engineers use the analysis to determine the probabilities and other properties of the soils. It is important to choose the correct type of soils for the construction project. In the experiment, the soil sample is a well-graded, very sandy gravel. The graph for particle size distribution also can be determined from the data taken. Next, the graph is used to determine other data such as D10, D30, D60, which is in this case 0.26 mm, 1.7 mm, and 60 mm. From this value, coefficient of uniformity CU and coefficient of gradation CD can be determined, which are 25.38 and 1.6. In conclusion, the objective of this experiment was achieved, which is to determine the particle diameter, the percentage passing, to plot the graph, and then we can also grade the characteristic of the soil, and then we can also determine the composition of the soil. Apparatus that is used for field density test is set of pouring cylinder, metal tray, hammer, nails, spade, and Ottawa sand. We weight the set of pouring cylinder and record the data, and then we pour the Ottawa sand into the set of pouring cylinder. Wait until the Ottawa sand fully pour down onto the cylinder, and then we weight the cone sand and the cylinder. The mass of sand cone also must be weighted. The mass of cone sand is recorded, and then we move to the field test. We dug a hole, and then following the metal tray size, we take the soil from the hole, and then we use the set of pouring cylinder to pour the Ottawa sand. Wait until the Ottawa sand is fully poured onto the hole, and then we take some of the soil samples to determine the moisture content of the soil sample using dish, and we weight the dish and put it into the oven and wait for 24 hours. After 24 hours, we weight the dried soil sample. This is the result that we achieved. For the field density test by using sand replacement method, the first step was to calibrate the cylinder to determine the weight of sand, and the sand used need to pass the 1.0 mm sieve pen. Next, mass of the inside cylinder was 1.581 kg. The density of pouring and sand calculated by dividing M3 and the volume of calibration cylinder, which was 1122.24 kg over meter cube. Field data taken, the values for field result can be determined, which are moisture content of removed soil, mass of sand ran out of cylinder, mass of soil in hole, bulk density and dry density. The moisture content calculated was 75.96%. For mass of sand ran out of cylinder, the value was 2.846 kg by subtracting M4 and 5. Next, mass of soil in the hole can also be determined by subtracting mass of sand ran out of the cylinder and mass of sand inside cylinder, which was 0.863 kg. For the volume of the hole determined was 6.96 times 10 minus 10 power of minus 4 meter cube. The bulk density and dry density can be calculated, which were 894.66 kg over meter cube and 509.45 kg over meter cube. Solution: the objective of this experiment is achieved, but there might be some experimental mistake in the conducting of this experiment, where if the amount of sand collected is different and the soil sample will not be sufficient to undertake this analysis, the test hole with a slightly different depth and quantity of dirt includes impurities that may affect the result of the density. The apparatus that is used in falling head test is U100 sample, standpipes with 3 different diameter, falling head meter, stopwatch and a bucket. Must place the soil sample fully into a triaxial cell on top of porous stone. Hole set up in a bucket partially submerged in water. Length and the diameter of the sample also must be recorded, and the diameter of the standpipe also recorded. Valve and fill the water into the standpipe to a marked initial height of the standpipe. Record the initial reading for height and time before the commencement of the test. Then, close the valve and start the test by observing the flow of water and time of the reduction. Once the flow of water reaches the final height mark, stop the time and record the final reading for height and time simultaneously. This is the result for falling head test. Discussion: the falling head test involved the flow of water through a very short soil sample attached to a standpipe that supplies the water head and enables the amount of water passing through the soil sample to be measured in the laboratory. The test then began by letting water to flow through the sample until the water level in the standpipe exceed a predetermined level. The time taken for the water in the standpipe with differing diameters to fall from the top level 0.80 meter to the lower level 0.30 meter is measured. The flow velocity generated by a hydraulic gradient of 1 can be defined as the permeability coefficient. The objective of this experiment was achieved, which is to determine the coefficient of permeability of soils. The procedure to perform this experiment was clearly understood. This experiment also allows engineers to measure of how easy water can flow through a soil's volume, and it is very important in geotechnical parameters. There might be some error occur during conducting the experiment, which in this case the soil sample used are all samples from the lab. The cost attribution is the student can learn how to conduct the experiment, and the course also keep the student to be creative, and lastly the course will expose student to apply the skill that they had learned